Good evening, guys. Welcome to HashLearn Studios and welcome back. People who have joined us from the previous session, we were looking at the last chapter of coordination compounds. In this, we will be looking at polymers, and the aim is to look at the initial part of polymers and also the reaction aspect of polymers. Now, if you've forgotten to subscribe to HashLearn, do that as the first thing right away. That's going to keep you posted about the examination details and the classes that we would be conducting in future as well. So it's going to help you in planning your schedule towards JEE. Moving ahead, to quickly recap the class, we looked at stability, importance, application aspect of coordination compounds along with numerical problems. So the CPP question which I had picked up, hope you guys have tried solving it. Aqueous solution of nickel sulphate on treating with pyridine and then adding a solution of sodium nitrite gives dark blue crystals. It is because of, you just have to look at the basic reaction between the given compounds. Nickel sulphate, pyridine and NNO2 gives which complex? It gives us this complex which is responsible for the dark blue coloration. So that is again a factual question. We have Sakshi joining us as the first candidate, followed by Yogesh. Welcome guys, good evening. And like I said, the goals of today's class is to look at classification of polymers along with another, I would say other couple of aspects of polymers and the numerical problems. So the next slide that you would be seeing is the first question for the day, guys. Proceed. A synthetic polyamide prepared by prolonged heating of caprolactam. So we are dealing with polymers and I'm asking you, if you heat caprolactam for a very long time, what would you get? So I have Shakir joining us and Sanjay. Welcome back Shakir, and warm welcome to you Sanjay. So good evening guys. So try to answer the first question quickly. A synthetic polyamide prepared by prolonged heating of caprolactam. And Peru has also joined us. Good evening Peru. Clock ticking. Quickly guys, quickly. Synthetic polyamide prepared by prolonged heating of caprolactam is, what is it going to be? Nylon 6,6, nylon 6, nylon 6,10 or glyptal. All of these are polymers, but which is prepared from caprolactam is the question. So take a couple of more seconds, but make sure you give me the answer. Yogesh says it's A. Shakir, Sanjay, Sakshi, Peru, quickly give me the answer. This is not a very difficult chapter. You should be able to give me the answer really fast. So I'll draw the caprolactam molecule for you. Peru and Sakshi, both of them say it is D. Caprolactam is this: N, H, 1, 2, 3, 4, 5, 6 carbons. There's a double bond O and there's an attachment like this. So this is caprolactam. Now if you heat caprolactam at around 260 to 270 degrees Celsius, heat caprolactam, this bond between nitrogen and carbon breaks. So you'll end up with NH. Since this bond is breaking, it will have a free valency, and you will have CH2. 1, 2, 3, 4, 5. CH2 5 times, and you will have C double bond O and a free valency. So Shakir, welcome. So Shakir has logged on using HashLearn website. That's the app. Welcome Shakir. Again, official welcome, I must say. So good going. Now if you see the bond breaks here, you have NH and C double bond O. The valencies become free here, and hence the polymerization can continue. Therefore this is caprolactam. If it breaks, which molecule is it going to form? It's going to form nylon 6. Why 6? What does this number 6 indicate? 6 indicate that there are 6 carbons in the molecule. So there's 5 here and 1 here, 6. So it is nylon 6. No worries, people were not able to give us the right answer, but I hope you guys have followed. Nylon 6,6 is what Yogesh said, and Peru and Sakshi said it's glyptal. No, both of them are formed from different monomers. If I have a single monomer which is going to help me in forming a polymer, it has to be caprolactam. Hope you guys have understood. Moving ahead, the monomer of Dacron. The monomer of Dacron. Let me see if this is going to help you. The other name for Dacron is pteryline. So pteryline and Dacron is same. Dacron is a polymer. So you just have to help yourself by recalling the names of the monomers used in Dacron or pteryline. Go ahead guys, really fast. These are not reasoning types. You know, you know. You don't know, you don't know. So try to recollect and answer instantaneously. Which one is it going to be? Clockmaster says time's up. Take a couple of more seconds. We have a good number of questions packed for you. Therefore, you need to answer it really fast. Dacron. Remember guys, Dacron is formed from terephthalic acid and ethylene glycol. So if you want to know what is terephthalic acid is benzene 1,4-dicarboxylic acid. This is terephthalic acid. And I'm quite sure you know ethylene glycol. Ethylene glycol is CH2OH. It's a diol, CH2OH. So there is condensation reaction happening and the molecule joins. Therefore, you have O, C double bond O, benzene ring, C double bond O, O, CH2, CH2O. This will be the polymer, and this polymer is called as Dacron or pteryline. It is formed from ethylene glycol and ethylene glycol, which is here, and terephthalic acid. Don't get carried away. This is not terephthalic acid. This is terephthalic acid. This is phthalic acid. Phthalic. This is terephthalic. So ethylene glycol and terephthalic acid. So Peru and Sakshi gave us the right answer. Yogesh says it is C. So Yogesh, C refers to Teflon. So the Teflon coating that you have on your non-stick pans, it is because of this compound. So moving ahead, thermosets are, what are these thermosets? Like I said, less than 10 seconds to answer this question. Cross-linked polymers. They are polymers, or they are plastics which doesn't melt or soften on heating. Cross-linking is usually developed at a time of molding where they harden. All of these above. So what are thermosets or thermosetting plastics or thermosetting polymers? Which one is going to be the right answer? Quickly. Cross-linked polymers, polymers that don't melt or soften on heating, cross-linking at the time of molding, or all of the above. Which one is it supposed to be? Yes, guys, let me tell you, thermosetting plastics. So Pooja has joined us. Good evening, Pooja. Welcome back. Go ahead and try to answer these questions, guys. What are thermosetting plastics? Thermosetting plastics are cross-linked polymers. So if you have a polymer chain, the polymer chains are cross-linked in multiple places. So cross-linked polymers is right. They don't melt on, or they don't melt or soften on heating. That is right. Whichever is cross-linked, you will not be able to change its shape. You will not be able to melt, or you will not be able to soften it on heating. This is also right. That's the property of cross-linking. And cross-linking is usually developed at the time of molding where they harden. So this itself gives us the answer. Cross-linking leads to hardening. So once it is hardened, it cannot be melted. It is permanently hardened. So this is also right. So the answer is all of the above. So Yogesh, Peru and Sakshi gave us the right answer. Shakir was close. Work on it, guys. I hope you guys have understood how it is. Cross-linking means hardening, and if it is thermoset, the name itself says thermoset. Once the shape is set or molded, You'll not be able to soften it or melt it and reshape it. Therefore, all of these options will fit in perfectly. Option D is the answer. Moving ahead, the catalyst used in the manufacture of polythene by Ziegler method. The catalyst. So, you know what is polythene? Polythene is ethene made into a polymer. Polyethylene, we'll shortly call it as polythene. So, Ziegler method. Ziegler-Natta catalyst is the name of the catalyst. What is Ziegler-Natta catalyst? Think about it. Quite an important catalyst. Even though in your 11th and 12th you'll not study much, but the application chemistry which is right now alive is polymer chemistry, and Ziegler-Natta or Ziegler catalyst is extensively used. So Pooja gives us the first answer. She says titanium tetrachloride and triethyl aluminium. Yes, she's right. What happens is polythene, if it has to be prepared by Ziegler method, the catalyst used is Ziegler-Natta catalyst, and Ziegler-Natta catalyst is nothing but triethyl aluminium in the presence of titanium tetrachloride. So triethyl aluminium in the presence of titanium tetrachloride. So Pooja, Yogesh, Sakshi gave us the right answer. Good going, guys. Titanium tetrachloride and triphenyl aluminium is A. What Shakir said, no, it is triethyl aluminium. Remember this: ethyl aluminium titanium chloride. So time to quickly answer the previous class's contest question. So the previous class's contest question was, which of the following shall form an octahedral complex? So we had given you 4 options: D4 low spin, D8 high spin, D6 low spin, and Z all of these. So the right answer is option Y, which is D6 low spin. So we had Sakshi and Pooja answering questions from the initial stage of the previous classes. So let me tell you, the right winner is Pooja. Pooja is joining us in this session as well. Congratulations, Pooja. You have won yourself an atom session. I'm quite sure that you're going to make good use of the atom session, wherein a question, a critical question I must say, or a concept that you post will be answered within 20 minutes of posting by our in-house experts, and it can be pertaining to any of the 4 core subjects. So congratulations once again. The answer is D6 low spin. The next slide that you would be seeing is the current classes contest question. Go for it, attack the problem. I won the right answer within 15 seconds of posting the question. Here we go. So hope you guys have successfully answered the contest question. We will let you know the winner in the next class of mine, which is tomorrow, guys. Till then, we will start answering really fast. Numerical problem 5. Chloroprene is obtained by addition of HCl2. So if you know what is chloroprene, chloroprene is the monomer used in the preparation of artificial rubber. That's synthetic rubber. So if you know what is chloroprene, excuse me, you'll be able to quickly answer the question. So go for it. Chloroprene is obtained by addition of HCl2, acetylene, vinyl acetylene, divinyl acetylene, and phenyl acetylene. So these are quite critical reactions based on this chapter. So you can answer this. Shakir, Pooja, Sakshi, Peru, Yogesh. Go ahead guys, go ahead, try to give us the answer. Chloroprene. If you think giving you the structure is going to help you, let me give you the structure as well. I have no worries. So Yogesh says it's 5A, CH2, double bond CH, CH2, double bond CH, C, triple bond CH. This is vinyl acetylene. You should know which is the acetylene molecule. This is the acetylene molecule, this is the vinyl molecule. So it is called vinyl acetylene. Vinyl acetylene molecule, when it is made to react with HCl in the presence of, the vinyl molecule in the presence of HCl, it ends up giving you CH2 double bond C. That is, this H is replaced, and instead of H you have Cl, and then you have C, and this double bond, one of the triple bonds is broken, and you get H double bond CH2. This follows Markovnikov's rule. Markovnikov or Markovnikov, you know that it can be pronounced both ways. This follows Markovnikov's rule, and therefore Cl is added to this, the one which contains more hydrogen, and the other one which contains less hydrogen. So it follows Markovnikov's rule, and this is the product. So this is chloroprene. It is nothing but 2-chloro-1,3-butadiene. 2-chloro-1,3-butadiene, and it is prepared from vinyl acetylene. Hope you guys have understood. So option B is the answer. So who gave us the right answer? Unfortunately, AD. So they were worried about acetylene and phenyl acetylene, but vinyl acetylene is the answer. Hope you guys have understood, guys. Reactions like these are not commonly available in most books, so I've made it a point to pick up questions where there is always a tendency to ask questions for the examination. So moving ahead to the sixth problem. A polymer which is used as a suture for stitching of wounds after operation. So during operations or cuts, when we stitch human skin or animal skin also for that matter, we use a particular polymer as thread. So that is called suture. So according to you, which polymer can be used as the thread which is used for stitching human and animal wounds? I'll tell you why it is chosen after you answer the question, but then tell me which is the polymer, or I can give you a clue. The polymer usually has to be a biodegradable polymer, so that the task of getting the threads removed after the stitches can be avoided. So you don't have to go back again after the wound has completely healed. You don't have to go back again and remove the thread, because the thread or the suture that they use automatically degrades within the body. Hence, another task of getting it removed is avoided. Therefore, we are worrying about biodegradable polymers. So which of it is the biodegradable polymer which can be used as a suture? Yogesh says it is D, Pooja B, Peru A. So which one is going to be the right answer? Peru is close. He says it's PHBB. PHBB is a biodegradable polymer, there's no doubt. Or this is also a biodegradable polymer. This is not a biodegradable polymer, but the right answer is dextran. So dextran is used for post-operative stitches. So after the operation, the stitches that we use, or the stitches that we make, the thread or the material that is used is dextran. So dextran is made up of glucose, which will automatically biodegrade. So Ria has joined us. Welcome to the webinar, Ria. Ria says it is D, but no, Dacron is not. And Sakshi and Peru were close, who says it is PHBV, which is also a biodegradable polymer, but it is not the right answer for this question. Hope you guys have understood. Moving on to the 7th question. Which of the following is a chain growth polymer? Which of the following is a chain growth polymer? Starch, nucleic acid, polystyrene, and protein. Chain growth polymer, which means the length of the chain grows step by step. So chain growth polymer. Which of it is the answer? Starch, nucleic acids, polystyrene, and protein. Questions like these can be answered really fast, guys. So have a look at it. Starch, nucleic acid, polystyrene, protein. Which of it, the length of the polymer chain grows step by step? So chain growth means the chain length elongates eventually. Which one is the answer? So we have Super Shark. Let me know if I can call you by another name. Super Shark. The name looks very interesting and intimidating, but it is more communicable if I can call you by your actual name. Okay. And C is what the first answer that I received. Then it is BB, and Ria also says it is C. So it is C, BB, and C. It is not nucleic acid, guys. Option C is right. It is polystyrene. Polystyrene is this. The styrene molecule is benzene ring with CH double bond CH2. So what happens is, on polymerization, one of the double bonds break and it becomes this. So this molecule goes on polymerizing with n number of entities joining to it. So the chain of the polymer grows step by step. So it's a chain growth polymer. Starch doesn't happen that way. Starch is a biodegradable natural polymer made up of amylose and amylopectin. Nucleic acids are polynucleotides made up of nucleosides, which are indeed made up of base, sugar, and phosphate group. So which is not also chain growth. Protein, you know, are polypeptides. So you'll have long chains of amino acids connecting to each other forming protein. So if it is joining segment by segment, it has to be polystyrene, and hence option C is the answer. So hope you guys have understood. Who has given us the shark, and Ria has given us the right answer. So proceeding to the 8th question, guys. Polyurethanes are polymers that contain urethane moiety. Moiety means center. So it contains a urethane center. A urethane can be prepared by treating an isocyanide with. So we are asking you what urethanes are. We have told you that polyurethanes are polymers, but our intention of the question is to ask you what urethane are. So try to give us an answer really quick. And urethane, it is mostly all of that high grade plastic that you use, right from shoe, slippers, sandal soles to plastics which can be repeatedly used without degradation. All of these soft plastics and all of these plastics which has a very long shelf life and which cannot be degraded very easily are made from urethane. So polyurethane has I must say ample applicational importance. So that is the polyurethane part for you. But quickly tell me, your urethane is prepared by what? So Yogesh says it is A. We have Supraja joining us. Welcome to the webinar, Supraja. And polyurethane, he says it is isocyanide. Let me quickly write the isocyanide molecule for you. It is R, N, double bond C, double bond O. This is isocyanate. All are telling me it is A. Guys, isocyanate plus alcohol. So the right answer is option B. So isocyanate plus alcohol will give me R, NH, C, double bond O, O, R dash. This is urethane. So urethane is not an amide, but it is related to amide. It is RC double bond O NH, but in this case it is RNH C double bond O OR. This is urethane, and urethane is formed from isocyanate as well as an alcohol moiety. So that's the answer for you, option B. Hope you guys register this. Quite an important feature when it comes to urethanes, because you guys don't study about urethanes at your level, but you need to know about urethanes as well when it comes to polymers. So this is where we can extend application into chemistry and chemistry into application part, and complicate it when it can come to all India level examinations. Moving on to the 9th question, guys. Caprolactam. The first question that I started the session with is caprolactam. So caprolactam can be obtained from benzaldehyde, cyclohexane, benzophenone, and adipic acid. If you know adipic acid is one of the reactant used to prepare nylon 6,6. So benzaldehyde, cyclohexane, benzophenone, adipic acid. What is it which is helpful in preparation of caprolactam? Caprolactam is the monomer which is used in the preparation of a polymer. Go ahead quickly. Benzaldehyde, cyclohexane, benzophenone, and adipic acid. So Ria says it is B. Yogesh says it is B. Yes, they are indeed right. Caprolactam is this. We already saw that. 1, 2, 3, 4, 5, and 6. 6 carbons. It breaks here and it forms a polymer chain. But let me tell you, it is starting from cyclohexane. So you take cyclohexane, you oxidize it, and you get cyclohexanone. You get cyclohexanone, and cyclohexanone will give you, sorry for that, cyclohexanone will give you cyclohexanone oxime. Cyclohexanone oxime. This is cyclohexanone oxime, which is nothing but caprolactam. So how will cyclohexanone give us cyclohexanone oxime? Through Beckmann's rearrangement. This comes under aldehydes and ketones aspect of organic chemistry. Beckmann's rearrangement, we have seen this. So a little more idea on this will follow in the upcoming question. So this is the entire process. You take cyclohexane, oxidize it to cyclohexanone, and on rearrangement you end up with cyclohexanone oxime, which is nothing but caprolactam. I'll definitely discuss this entire mechanism as it is important. So the answer is cyclohexanone. Moving ahead, Peru, Sakshi, Ria, Yogesh gave us the right answer. So no worries, guys. Keep learning. That's the entire purpose. Numerical problem 10. In the isoprene polymer, all the isoprenes have. That's all the isoprenes have. So isoprene polymer is natural rubber. I told you that chloroprene is the monomer for synthetic rubber. Just like that, isoprene is the monomer for natural rubber. So you just have to know what is isoprene. If you know isoprene, you can answer this. Isoprene is the monomer for natural rubber. Quickly. In the natural rubber, all the isoprene units have trans 1,4 configuration, cis 1,4 configuration. Easy to answer. Both cis and trans, and D, none of these. Which one has to be the right answer? Trans, cis, both, none of these. We have Sajid also joining. Welcome to the webinar, Sajid. You've joined us a little late, no worries. Another couple of questions packed, but then we've just started with the lecture series of polymer chapter. So you've joined us at the right moment. In the isoprene polymer, all the isoprene units have trans 1,4, cis 1,4, both cis and trans, and none of these. So Sajid, Yogesh say it is B. Yes, guys, it is indeed B. Isoprene is nothing but CH2, CCH3, CH2, I must say CH, double bond CH2, that is 2-methyl 1,3 butadiene. Butadiene is called as isoprene. This is isoprene, and this is what natural rubber is made up of. So natural rubber will polymerize, and you need to remember that natural rubber is always made up of cis 1,4 configuration of isoprene. It's always cis. Do not remember 1,4, it's okay, but cis configuration of isoprene is what makes up natural rubber. And you also should remember that it can be another possible question. When trans 1,4 configuration of this molecule is used, when trans 1,4 configuration of this molecule is used, we will call it as, it has a special name, gutta percha. So this is the name of the polymer that we use, or that we get, I must say, when isoprene is present in trans form. When it is in cis form, it is natural rubber, which is isoprene, and when it is in trans form, we get another polymer called as gutta percha. So Sajit, yes, I acknowledge that. So that's a nice name, Sajit. So gutta percha, another extra information. Remember this. So natural rubber and gutta percha. Moving ahead, guys, to the 11th problem. The tensile strength of vulcanized rubber is almost 10 times more than raw rubber. We have given you two statements, and relating to those two statements, we have asked you to find out the answer. So tensile strength of vulcanized rubber is almost 10 times more than raw rubber, and elasticity of raw rubber is very high. So which is the right answer? 1 is true, 2 is false. 1 is false, 2 is true. Both 1 and 2 are true. Both 1 and 2 are false. So it has to be both 1 and 2 are false. So what is it going to be? You can answer really fast. Tensile strength. Tensile means elasticity. So elasticity of vulcanized rubber is almost 10 times more than raw rubber. That is the right statement. Elasticity of raw rubber is very high. He has told that tensile strength of vulcanized rubber is 10 times more than raw rubber, which is true. Elasticity of raw rubber is very high is wrong, which means statement 1 is true and statement 2 is false. It has to be option A. Remember this, guys. What's the purpose of vulcanization? If you remember, good 150 years back, it was Goodyear who first, Goodyear, now you have a lot of tires with that name, Goodyear. Goodyear was the first person to introduce vulcanization. So he said, I can make rubber moldable, I can make rubber tensile, it can have high levels of elasticity if I add a little sulfur to it. So the moment they add sulfur to it, what happens is the polymer chains, the natural rubber's polymer chains will start cross-linking, and the cross-linking is using sulfur. So the moment I add sulfur, then that will not excess 3 to 5% of sulfur. The moment 3 to 5% of sulfur is added, cross-linking of natural polymer chains of rubber happens, and this cross-linking is what leads to the increase in the tensile strength, and hence rubber becomes more moldable. It is not too liquidy, that is, it is not fluidy, and hence can have really high mechanical and tensile properties associated with it. That's the entire story of vulcanization for you. Okay, and option is A. So all of you have given me the right answer. Yogesh, Sajit, Sakshi says it's B. That's okay. Hope you have understood Sakshi. Others have given me the right answer. No, Sakshi says it's A. I'm really sorry. So that was for the previous question. So most of you have given me the right answer. So we have another person joining us, Optimistic Ocelot. I hope I have pronounced that right. I don't know, we have people joining us with a little not so common names. So is that supposed to be an option? He or she has given me a symbol here, but I don't think it matches with any of our answers. So let us see quickly. Go ahead and let me know what's the answer, madam or sir. Select the incorrect statement. That's problem number 12 for you guys. Select the incorrect statement. For natural polymers, PDI. PDI stands for polydispersity index. For natural polymers, PDI is generally 1. Natural polymers are more homogeneous than synthetic polymers. For synthetic polymers, PDI is generally 1. The polymers whose molecules have nearly same molecular mass, PDI is 1. So yes, Sajit, yes, I acknowledge this, Sajit. So thank you for changing your username. It becomes more communicable now. Acknowledge that. Thank you. Now quickly, try to give me the right answer, which is the incorrect answer for the following question. For natural polymers, PDI is generally 1. or it is not homogeneous. PDI is 1 for synthetic polymers, and polymers whose molecules of nearly same molecular masses have PDI equal to 1. So Sajid says C, Yogesh says C, and Sakshi Pandey also says it is C, which is the incorrect statement. Yes guys, you guys are right. The incorrect statement is PDI for synthetic polymers is generally 1. PDI for synthetic polymers is more than 1 or sometimes less than 1. What is polydispersity index? PDI stands for polydispersity index. Polydispersity index means if I have a polymer made up of a lot of polymer chains, if the length of the polymer chains are almost same, then the polymer will be considered homogeneous. So if I am made up of homogeneous polymer chains, then I say the polydispersity index is 1. And if I have polymers made up of abnormal polymer chain lengths, then I'll say that this polymer is heterogeneous with respect to chain length, and it should have polydispersity index either greater than 1 or less than 1. So always remember, natural polymers polydispersity index is 1, which means it is homogeneous. Natural polymers, that's exactly what is said here. And polymers whose molecule have nearly same molecular masses. Nearly same molecular masses means the chain lengths are almost same. If the chain lengths are almost same, it means the same thing. Its polydispersity index is 1. And artificial or synthetic polymers will have polydispersity index either more than 1 or less than 1. So option C is the right answer, which most of you have given me. Moving ahead to the 13th question. Beckmann rearrangement is involved. Another 3 questions packed for you guys. Beckmann rearrangement is involved in the synthesis. I told you this Beckmann rearrangement with respect to caprolactam. Caprolactam is formed from cyclohexanone, cyclohexane, oxidation, cyclohexanone on rearrangement. That's Beckmann's rearrangement. You get caprolactam or cyclohexanone oxime. Pertaining to that, try to answer this question. Beckmann's rearrangement is involved in the synthesis of the following polymers. Which one is it going to be? Option A, PAN. PAN stands for, Clockmaster says time's up, but PAN stands for polyacrylonitrile, nylon 6,10, nylon 6, and melamine. So Sajid says it's C, Yogesh says it's C. Yes guys, it is indeed C because I gave you the details of the reaction. Nylon 6 is formed from caprolactam, and caprolactam is indirectly formed by Beckmann's rearrangement. Like I said, I'll give you the entire overview. Try to understand this. So we start with cyclohexane. So Sakshi also gave us the right answer. We have Anurup joining us. Welcome to the webinar, Anurup. You've joined us at the last moment, but that's okay. Make the most out of the questions that we are yet to discuss. Pooja says it is C. Guys, it is not C. It is, I'm sorry, it is indeed C. I'm sorry. Peru says it is A, but nylon 6 is the answer. I'm giving you the theory behind it, guys. Try to understand. Take cyclohexanone, oxidize it. Cyclohexane, oxidize it. You will get cyclohexanol. Cyclohexanol, oxidation, cyclohexanone. And cyclohexanone is made to react with NH2OH. NH2OH, you should know what it is. It is hydroxylamine. Hydroxylamine. The moment it is made to react with NH2OH, you end up with double bond NOH. This is cyclohexanone oxime. This will undergo Beckmann's rearrangement. This will undergo Beckmann's rearrangement in the presence of sulfuric acid. So it leads to the formation of C double bond O NH. This is caprolactam. So this is the overall reaction that I was talking to you guys about. See, the only rearrangement that matters here is Beckmann's rearrangement. This is caprolactam, and caprolactam on heating to around 260 to 270 degrees Celsius, prolonged heating will give you this bond will break here. So you will end up with NH, 1 carbon, 2 carbons, 3, 4, 5. So 5 carbon, that's CH2 5 times, and then C double bond O and a free bond. So this is how the polymerization will occur. So Beckmann's rearrangement plays an important role in the formation of nylon 6. Hope you guys have understood, and most of you have given us the right answer, but this is the involved theory behind the answer, guys. This will help you in concretizing the knowledge, whatever basic knowledge you had. This gets concretized using that. Now moving ahead, this is the last question packed for today's class. Buna S. In Buna S, S stands for. So what is Buna S? If you know what is Buna S, you'll know what is S there in Buna S. Sulfur, sodium, synthetic, and styrene. So quickly, shouldn't take us too much time. All these questions less than 10 seconds to be solved. Sulfur, sodium, synthetic, and styrene. S stands for what? First. Yes. So Sajid says it is D. Yogesh says it is D. Okay, Sakshi also says it's D. Peru, Pooja, Ria, Anurup. Go ahead, guys. Go ahead and try to answer. Optimistic Ocelot. Go ahead, guys. Go ahead and try to answer. Yes, it is indeed styrene. All of you have given me the right answer. Buna S. Buna S stands for Bu, butadiene, Na, sodium, and S stands for styrene. So Buna S is indeed butadiene, sodium, styrene. So butadiene is CH2 double bond CH, CH double bond CH2. Styrene is benzene ring and CH double bond CH2. Sodium will act as a catalyst. So there is polymerization reaction occurring. The polymerization reaction is double bond shifts this side and the valencies become free. So you have CH2, CH double bond CH, CH2. The valency becomes free here, CH2, and then this valency becomes free. So CH benzene ring and CH2. This is n times. This is Buna S. This is the overall polymer Buna S, which stands for butadiene, sodium, and styrene. So like I said, classification was the intent, but we moved beyond that as well. We threw some light on classification, and we looked at a lot of other numericals to do apart from classification as well, guys. And thank you so much. The participation was really brilliant, and the best part is most of you ended up giving us the right answer, which means you're in I would say in context with your upcoming exams, that's JEE. So good job, guys. If you have liked the class, please go ahead and share, and the next class of mine is tomorrow. So we'll have 2 sessions there packed exclusively for you guys. So we have increased the number of classes so that it's going to be helpful, and that's a little thing that we can do from HashLearn. So that's going to be as a gift to you guys for your upcoming JEE exam. So we have 2 sessions packed for you for tomorrow as well, 6:15 to 7 and 7:15 to 8. So looking forward for your active participation, and if you have liked their classes, guys, please go ahead and share. Make sure that others are also benefited from classes of ours, and so Passport subscribers, you have access to CPP, and go ahead, please solve the CPP questions within the heat of the moment so that everything gets properly impregnated into your minds. And if you have not subscribed to Passport, all that you have to do is just a couple of clicks, and you'll have access to CPP questions that we release after every session of ours. And apart from that, one-on-one doubt solving sessions. The best part is it is 24/7, so you will have all of your doubts immediately answered no matter when you post your question. And apart from that, practice questions, tests from some of the best-selling books, and also all the video classes covering the toughest concepts and problems. So for now, it's a chemistry teacher signing off. See you tomorrow, guys. Good night.